Hi students, good morning. In the last class, we have discussed the concepts of the binomial theorem. In this session, also continuing another concepts and some related problems we are going to discuss. Okay, let us start. Okay, see the concept. Trinomial expansion. In previous we have discussed the binomial expression. Here the trinomial expansion. What is the trinomial? Tri means 3. So in that 3 terms now we are taken a plus b plus whole to the power of n. These are the 3 terms that is the expansion of a plus b plus c whole to the power of n is we are taken trinomial expansion. See that the concept here. Let n belongs to capital N. N is a natural number and small a, small b, small c are real numbers. Then a plus b plus c whole to the power of n. A plus b plus c whole to the power of n can be expressed using the binomial theorem by taking a as the first term. We are taken a as the first term and b plus c as the second term as follows. Here a plus b plus c whole to the power of n is equal to a plus b plus c whole to the power of n. That can be written as sigma r is equal to 0 to n. NCR, first term is a to the power of n minus r. The second term is b plus c whole to the power of r. We are expanding like this. In this expansion, what are the number of terms in this expansion? The number of terms in this expansion is n plus 1 into n plus 2 by 2. So this is the number of terms in this expansion. So what is the another form of this expansion is representing here a plus b plus c whole to the power of n. A plus b plus c whole to the power of n is equal to sigma n factorial by p factorial, q factorial, r factorial into a to the power of p and b to the power of q and c to the power of r. Now we are express this expansion a plus b plus c whole to the power of n is like that sigma n factorial by p factorial, q factorial, r factorial into a to the power of p, b to the power of q and c to the power of r, where p plus q plus r is equal to n. The sum of these terms p, q, r, the sum of these factors is equal to n. So this is the trinomial expansion. So in our intermediate syllabus, what is the number of terms in the trinomial expansion and some related problems, few problems are in this syllabus. So most of all we are to discussing the binomial expansions. Okay, see the problem. Find the number of terms in the expansion of 2x plus 3y plus z whole to the power of 7. This is our problem. See the solution. See the solution. So what is the given expression? So what is given expression is given that the expression is that is 2x plus 3y plus z to the power of 7. Here the number of terms in this expansion 3. 2x is one term and 3y is another term and z is another term. These are 3 terms. This is the trinomial expression. So in the trinomial expansion, the number of terms is the we are previous discussing. The number of terms in trinomial expansion is n plus 1 into n plus 2 by 2. So here n is here n is 7. So the power index is that is 7. The number of terms terms In this expansion, what is the formula? N plus 1 into n plus 1 into n plus 2 by 2. This is the formula. In trinomial expansion, the number of terms is n plus 1 into n plus 2 by 2. Here, what is n? N is 7. That is 7 plus 1 into 7 plus 2 by 2. By 2. That is 7 plus 1, 8 into 9 by 2. That is 2, 4 is 8. That is 30. 4 9s are 36. The number of terms in this expansion is 36. So here we have taken this 2x is one term, not taken two terms. This is only one term, and 3y is another term, and z is another term. So this expansion is expression is the trinomial expression. In this expansion, the number of terms is the formula n plus 1 into n plus 2 by 2, or otherwise the formula is remembering n plus 2 C2, n plus 2 C2, where the number of terms in the trinomial expansion is we have taken n plus 2 C2. That is the formula n plus 2 into n plus 1 by 2. So we are also remembering this n plus 2 C2. That is the number of terms in the trinomial expansion is denoted by n plus 2 C2. That is n plus 2 into n plus 1 by 2. So this is the formula for finding the number of terms in the trinomial expansion. See that here numerically greatest term. What is the numerically greatest term in the expansion of 1 plus x whole to the power of n? So that is the concept here. The numerically greatest term in the expansion of 1 plus x whole to the power of n. 1 plus x whole to the power of n. In this expansion, what is the numerically greatest term? We have to find. So we are finding as follows. First we have to find the m. That is m is equal to step of n plus 1 mod x by 1 plus mod x. That is the value. M is equal to step of or box of n plus 1 mod x by 1 plus mod x. What is the step function? You know that the step function, suppose so step of x. What is the step of x? X is the least positive integer. We have taken x is any real number. The step of where x is we have taken any real number. Then step of x is the least positive integer. Suppose here we have taken, so that is n less than or equal to x less than n plus 1. This is the least positive integer. That is the definition of the step x. Suppose we are taken x is equal to 5.12. Then what is step of x? That is step of 5.12. That is we are taken, that is the least positive integer. This 5.2 is between that is 5 less than or equal to 5.2 less than 6. Okay, so the least value of this is 5. So that is the least positive integer of this real number. X is equal to 5.2, that is we are taken, so that is 5. So step of 5.12 is we are taken 5. So this is the concept behind the step function. So now we have to take the m is the step of n plus 1 mod x by 1 plus mod x. So first we have to find the m value. So after that we are observing these two cases. If the value n plus 1 mod x by n plus 1 mod x by 1 plus mod x is not an integer, so that is the value of n plus 1 mod x by 1 plus mod x is not an integer, then t m plus 1 is the numerically greatest term. In this case t m plus 1 is the numerically greatest term. Suppose the second case is if n plus 1 mod x by 1 plus mod x is an integer. We are getting this value is an integer. Then we are getting two numerically greatest terms. Those are tm and tm plus 1 are two numerically greatest terms. Suppose if we here we are taken the m value is suppose m is equal to step of 5.12. Step of 5.12. So here this value is not an integer. That is the n plus 1 mod x by 1 plus mod x is equal to suppose the value is 5.12. Then we are taken m is step of 5.12. What is here step value of this 5? So here m is 5. Then what is the numerically greatest term? Then in this case numerically greatest term is tm. Sorry, so it is not integer, tm plus 1, that is m plus 1, that is t5 plus 1, that is t6. If it is not an integer, the value n plus 1 mod x by 1 plus mod x is not integer. Suppose this value is 5.12, it is not integer. Then we have taken m is step of 5.12, that is 5. Then what are the numerically greatest terms? T m plus 1 is only one numerically greatest term, that is t 5 plus 1, that is t6. So this is the about case 1. This is the case 1. Suppose the case 2 we are observing here. Suppose this value n plus 1 mod x by 1 plus mod x, that value is 10. Suppose this value is an integer. Then what is the numerically greatest term? So now we have taken that m is equal to what is step of 10. Here step of 10 is it is an integer, therefore that is 10. Then what is the numerically greatest terms here? tm and tm plus 1 are the numerical greatest terms. There are two numerically greatest terms, that is t10 comma t10 plus 1 are numerically greatest terms. If this value is not an integer, then we are getting the step of this value, that is taken m. Then after we have to write the numerically greatest term is tm plus 1. tm plus 1 is the numerically greatest term. This term is not an integer. If this term is an integer, then we are getting two numerically greatest terms. Those are tm and tm plus 1. These two are numerically greatest terms. This is the concept of the numerically greatest term. This is very important for IP and also JEE mains. If we given expression and find the numerically greatest term in that expansion. Okay. See the note here. Prove that for any real numbers small a comma small d. Here the result is a c naught plus a plus d c1 plus a plus 2d c2 and so on. A plus nd into cn is equal to 2a plus nd into 2 to the power of n minus 1. So this is the result. It is very important and so many times it is useful. Okay, now we are proving this result is a c naught plus a plus d c1 plus a plus 2d c2 and so on a plus nd cn. We are observing the coefficients of c naught, c1, c2 and so on cn. These are a plus d, a plus 2d, a plus nd. These are the terms in the series of AP. So these are the terms in AP. Then we have to result is here 2a plus nd into 2 to the power of n minus 1. This expansion is equal to 2a plus nd into 2 to the power of n minus 1. Now we are proving this result. Okay. So proof is we are proving this result. Okay. Let we are taken let S is equal to we are taken LHS. What is LHS here? A C naught plus A plus D C1, A plus D C1 plus A plus 2D C2 and so on plus A plus ND, A plus ND into Cn. We are taken LHS of the given result. Now we are taken this is S. S is the this one. Now we are writing. From last to first. We are taken this is yes. So this is the S is we are writing A C naught A plus D C1 and so on A plus N D Cn. Now we are writing from last to first. Now we are taken last to first. That is first we are writing the last term, that is A plus Nd into Cn. Now we are write this is Cn. This is say equation 1. Now we are writing. So after this before this term is A plus n minus 1 into D Cn minus 1 and so on and so on. So these are the last two terms, A plus D C1 plus A C naught. This is now we are taken so now we are simplifying first this one. Now this is here C naught. What is C naught? We know the formula. We are writing here. So what is NCR is equal to NCn minus R. This is the known formula. NCR is equal to NCn minus R. So we are taken this is suppose NCn, that is NCn minus n, that is the formula, that is NC naught, like that. So the first terms and last terms are equal. So C naught equal to Cn, C1 is equal to Cn minus 1, C2 is equal to Cn minus 2 and so on. So this is the concept. Okay. So here the first terms and last terms are both are equal. Here C naught equal to Cn. Here C1 is equal to Cn minus 1. Now we are writing Cn is C naught. Now in this step we are writing A plus Nd into C naught. Here A plus n minus 1 into D into C n minus 1, that is C1, that is NC n minus of n minus 1, that is n minus n is cancelled, that is minus or minus plus 1. Now writing like that. Here the last terms that is okay, that is here. Now we are writing this one. So Cn is C naught, Cn minus 1 is C1 and so on. This is A plus D Cn minus 1 A Cn. C naught is Cn, C1 is Cn minus 1. Now we are taken this as equation 2. Now we are taken this as equation 2. Now we are adding 1 and 2 equations. Now we are adding these two, 1 plus 2. Okay. Now we are adding 1 plus 2. Now so adding these two equations, this equation and this equation. We are adding these two equations, S plus S, that is 2S. That is 2S is equal to here A C naught, here A plus ND C naught. So in these two terms C naught is common. Okay, C naught is common. Then remaining terms are A plus A plus ND into C naught. Now we are adding these two terms, that is here C1 is common, then the remaining terms we are adding. So that is here A plus D, here A plus D, in this A plus n minus 1 into D into C1. C1 is common. Okay, like that we are common. And the last term, so that is this one. Here in equation 2, A C naught, where Cn is common, we are getting A plus Nd plus A into Cn. In this Cn is common, A plus ND plus C. Okay. Now we are observing this one here 2s is equal to here A plus A, that is 2A plus ND into C naught. Here A plus A, that is 2A. Here, so n minus 1 into d, that is n into d minus d. Minus d plus d will be cancelled. So again we are getting here nd into c1 and so on. In the last term is also a plus a, that is 2a plus nd into cn. Now we are adding equation 1 and 2. Then we are getting 2s is equal to a plus nd c naught. 2a plus nd c naught, 2a plus nd c1 and so on 2a plus nd cn. In RHS 2a plus nd is common, that is 2a plus nd is common. Then we are getting c naught plus c1 plus c2 and so on cn. Okay, that is equal to here 2a plus nd, 2a plus nd is equal to, we know that the formula in the last class we are deriving c naught plus c1 plus c2 and so on cn, that is the sum of binomial coefficients. Sum of the binomial coefficients. This is the formula. This is the formula. Sum of the binomial coefficients c naught plus c1 plus c2 and so on cn is equal to 2 to the power of n. So this result is in previous class we have discussed. Okay, so the sum of the binomial coefficients is 2 to the power of n. Okay, now we are getting here, that is here LHS is 2s. Okay, now from that s is equal to, that is 2a plus nd into 2 to the power of n by 2, that is this 2 is moving to this side, that is 2 power n by 2, that is 2 to the power of n minus 1. We are getting the result this one, that is yes. What is yes? That is a c naught plus a plus d c1 plus a plus 2d c2 and so on a plus nd cn is equal, that is yes. S is equal to, we are getting the 2a plus nd into 2 to the power of n minus 1. So that is our required result. So the sum of the series a c naught plus a plus d c1 a plus 2d c2 and so on a plus nd cn is equal to 2a plus nd into 2 to the power of n minus 1. So we are observing in the binomial coefficients c naught, c1, c2, their coefficients are a plus d, a plus 2d, a plus nd. These are in AP. If the coefficients of binomial coefficients are in AP, then we are taken, this is the result, that is the 2a plus nd into 2 to the power of n minus 1. Okay, see the note here. If n is positive integer, then these are the results. So first one is sigma r is equal to 1 to n r into cr is equal to n into 2 to the power of n minus 1. So in this expansion we are getting 1 c1, 2 c2, 3 c3 and so on n cn. So this is the result. Here this is the result, that is 1 into c1, 2 into c2 and 3 into c3 and so on. This is and n cn, n into cn. That value we have taken, this is n into 2 to the power of n minus 1. This is the result, this value, that is 1 c1, 2 c2, 3 c3 and so on n into cn. That value is n into 2 to the power of n minus 1. So next result is sigma r is equal to 1 to n r into r minus 1 into cr is equal to n into n minus 1 into 2 to the power of n minus 1. So this is the, here sigma r is equal to, this is r is equal to that is 2 to r is equal to 2 to n. That is the result. That is 2 into 2 minus 1 into C2. So here we are getting in this this is the expansion, that is say taken from R is 2 to n. So that is 2 into 2 minus 1, that is 1, C2, 2, C2, 2 into 2 minus, sorry, next we are taken 3 into 2, 6 into C3, that is 3, 3 minus 1, that is 2, 2 into 3, 6, and so on. This series were taken n into n minus 1 into 2 to the power of n minus 2. This result is we are using in the problem. So that is the series 2, C2, 6, C3, and so on. That series value is n into n minus 1 into 2 to the power of n minus 2. Okay. Next, third result is sigma R is equal to 1 to n R square into CR is equal to n into n plus 1 into 2 to the power of n minus 1. So in this expansion, this series is 1 into C1. This series is 1 into R is equal to 1. 1 square is 1. 1 C1, that is 2 square, that is 4. C2, that is 3 square, 9. C3, that is and so on. This expression value is we have taken n into n plus 1 into 2 to the power of n minus 2. So this is the see the problem. Expand the following using binomial theorem. So this is the given expression is 4x plus 5y whole to the power of 7. Now we are expanding this. So see the solution. So what is the given expression? Given expression, that is 4x plus 5y whole to the power of 7. Now we are expansion using the binomial theorem. So what is the here? The expression is 4x plus 5y whole to the power of 7. So this is the first term, that is 4x, and the second term is 5y. Here index is 7. We are writing the expansion, that is n c naught, that is 7 c naught into first term, that is 4x whole to the power of n, that is 7, into second term, that is 5y whole to the power of 0. Next term 7 c1, 4x whole power 7 minus 1, that is 6, into 5y whole power 1. Next 7 c2, 4x whole power, here 4x powers are decreasing, here 6, next is 5, and second term powers are increasing, here 1, here 2, and so on, and so on, and so on. So next what is we are writing the 7cr 4x whole power 7 minus r, 4x whole power 7 minus r, into second term, that is 5y whole power r, and so on. This is the r plus 1 term, and what is and so on. The last term 7c7 into first term is 4x whole power 0, and second term 5y whole power 7. So these are the terms we are getting the in this expansion 4x plus 5y whole power 7, that is 7c naught, first term to the power of 7, second term power 0, 7c1, 7c2, 7c3, and so on. So we are getting here in the middle term. So that is the last term is 7c, 7, 4x whole power 0, and 5y whole power 7. So this is the expansion. Okay. Now we are just write another step, that is 4x plus 5y whole power 7 is equal to, that is 7c naught, 4x whole power 7, 5x whole power 0 is 1. Next 7c1, 4x whole power 6 into 5y plus 7c2, 4x whole power 5 into 5y whole square, 7c 3 4x whole power 4 into 5y whole cube, next plus 7c 4x whole power 3 into 5y whole power 4, 7c 5 4x whole square into 5y whole power 5 plus 7c 6 4x whole power 1 into 5y whole power 6 plus 7c 7, here 4x whole power 0 is 1 and 5y whole power 7. So this is the expansion of the given expression, that is 4x plus 5y whole power 7. We are using the binomial expansion. This is the expansion of the given expression 4x plus 5y whole power 7. Okay, see the another problem. Write down and simplify. These are the some given problems. In that first one is sixth term in 2x by 3 plus 3y by 2 whole to the power of 9. In this expansion, we are writing the sixth term. Okay, so that is the problem. See the solution here. See the solution here. What is the given expression? This is the solution. So given expression, given that is 2x by 3 plus 3y by 2 whole to the power of 9. So this is the given expression, 2x by 3 plus 3y by 2 whole to the power of 9. This is the given expression. Now we have to write the sixth term in this expansion. Now we are writing the sixth term, that is what is the general term in the binomial expansion, that is TR plus 1. TR plus 1 is the general term. How to write the general term? That is the formula NCR, the first term x to the power of n minus r into a to the power of r. Here x is the first term and a is the second term. This is the formula for finding the general term TR plus 1. Okay, now we are writing the sixth term. Now we are writing the sixth term. Sixth term, that is T6. That is T6. T6 is the sixth term. That 6 can be written as 5 plus 1. Now we are converted into this form TR plus 1. We are taken R is 5. So we are taken R is 5 and here n is 9 and first term is 2x by 3 and second term is 3y by 2. Now we are writing the sixth term, that is T 5 plus 1. Here n is 9. Here n is 9. 9c R is here 5. 9c 5 into, that is the first term. What is the first term here? That is 2x by 3 whole to the power of, that is n minus r. That is n is 9 minus r is here 5 into, what is the second term? That is 3y by 2. 3y by 2 whole to the power of r. This is the sixth term. That is T6 is equal to 9c5 into 2 by 3 into x power 9 minus 5 into 3y by 2 whole to the power of 5. Now we are writing this one, 9c5 into, that is here 9 minus 5, that is 4. That is we are getting 2 power 4 by 3 power 4. That is 9 minus 5 is 4. 2 power 4 by 3 power 4 into x to the power of 4. Here power is 4 and into, this is 3 power 5 by 2 power 5 into y to the power of 5. Now we are simplifying this one, that is 9c5 into, here 3 power 4, here 3 power 5, that is 5 minus 4, that is 1. Here 2 power 4, here 2 power 5, that is 5 minus 4, that is 1. We are getting only in the numerator is that is 3. In denominator is 2. In denominator is 2. Here 2 power 4, here 2 power 5. 2 power 5 minus 2 power 4, 5 minus 4, that is 2 power 1. Here 3 power 5 by 3 power 4, that is 3 by 2. Next, into x to the power of 4 into y to the power of 5. Now we are calculating this value 9c5. Now we are writing here what is 9c5. We are studying these values in permutation combinations. What is 9c5? How to get the value? Here 9c5 is nothing but 9c, 9 minus 5, that is 4. So 9c4 can be written as 9 into 8 into 7 into 6. Now we are writing 4 terms from 9 to the decreasing values. So by 4 factor, 4 into 3 into 2 into 1. So 9c5 can be written as NCR is equal to NC n minus R. 9 minus 5, that is 4. So here 9c4, right, in this way 9 into 8 into 7 into 6. Now we are writing 4 terms in the numerator. So 9 to 6. Okay, that is decreasing the integers. So 9, 8, 7, 6 by, that is 4 factorial. So here 3 into 2, 6. Okay, next 4 2s are 8. That is 9 2s, that is 18 into 7. Okay, that is 9 8s are 56. So 9 7 plus 5, 7 plus 5, that is 125. Okay, that is 126. Okay, that is 126 is 9c5. That is 126 into 3 by 2 into x to the power of 4, y to the power of 5. Here 2 6 jar 2 3s are 63s. Okay, that is 3 3s are 9, 3 6s are 18. 189 into x to the power of 4, y to the power of 5. So what is the sixth term? Therefore here sixth term is we are getting this is value 189 into x to the power of 4 into y to the power of 5. So that is the sixth term in the given expression. In the expansion of given expression, the sixth term value is 189 into x to the power of 4 into y to the power of 5. So here we are writing the values of NCR. So we are writing NCR, that is n factorial by n minus r factorial to r factorial, that is one way. Another way is 9c5. Now we are reducing here suffix by NCR is equal to NC n minus r, that is 9c, 9 minus 5, that is 9c4. Now 9c4 can be written as 9 into 8 into 7 into 6 by 4 factorial, 4 into 3 into 2 into 1. So we are getting 9c5 is 126. Here we have substitute 126. Here remaining terms 3 by 2 into x power 4 into y power 5. So after calculation we are getting 189 into x to the power of 4 into y to the power of 5. Okay, see the problem. Find the number of terms with non-zero coefficients in the expression. 4x minus 7 whole power 49 plus 4x plus 7y whole power 49. So in this expansion, what are the number of terms? These terms are with non-zero coefficients. Okay, now we have to find the number of terms in this expansion. See the solution. See the solution. So given expression is now we are given the expression is that is 4x minus 7 whole power 49 plus 4x plus 7 whole power 49. This is the given expression. Now we have to find the number of terms in this expansion. Okay, now we are writing the expansions of these two binomial terms. So I am writing here, that is n is here 49 C naught 4x whole power 49 into second term power is 0. Okay, here minus, then we are getting plus minus alternatively, that is 49 C1 into 4x whole power 48 into the second term 7 to the power of 1. Next 49 C2 4x whole power 47 into 7 square minus 49 C3 4x whole power 46 into 7 cube and so on and so on. The last term is that is 49 C 49 7 to the power of 49 7 to the power of 49. Here the 49 is negative, where the last term is negative. Okay, and so on this one. This is the 4x minus 7 whole power 49. So this is the expansion of first expression. Next we are writing plus the second term expansion. So these two are same, but here minus, here plus. Okay, in the expansion the values are plus values. Okay, the same terms we are writing 49 C naught 4x whole power 49. Here we are getting plus. All terms are plus terms. Here 49 C1 4x whole power 48 into 7, 49 C2 into 4x whole power 47, 7 square plus 49 C3 4x whole power 46 into 7 cube and so on, plus 49 C49 7 power 49. Okay, these are the expansions of the given binomial terms. Here the terms minus 49 C1 4x whole power 48 into 7. These are, one is value plus and another is minus. So these two terms are cancelled. Similarly 49 C3 plus minus value and 49 C3 plus term is cancelled. So remaining terms are 49 C0, here 49 C0, the same terms, and also 49 C2, here 4x whole power 47 into 7 square. These are all same terms. So this is double. Okay, the terms are, each one is double. So that is 2 is common. Then we are getting 49 C0 4x whole power 49. Next 49 C2 4x whole power 47 into 7 square plus so on. Okay, so the last term 40. So these will be cancelled. The before term is 49 C 48 into 4x whole power 1 into 7 to the power of 48. These are the remaining terms. Now, what are the number of terms in this remaining terms? In this expansion, the remaining terms are, these are the remaining terms. So, what are the, how many number of terms in this expansion? So, here observing 49 C0. Okay, here 49 C2 up to here 49 C 48. Okay, now this is the, that is C2, that is 2 into 1, here 2 into 1, and next 2 into 2 and so on, 2 into 24. So these are the terms 2, 1, 2, 3 and so on 24. So the terms are 24 from 49 C2 to 49 C 48. So these are 24 terms. These are 24 terms. These are 24 terms. This is another term 49 C0 4x whole power 49. So the total number of terms in this expansion. Therefore, the number of terms in this expansion, in this expansion is equal to the total number of terms is here. These are the 24 terms. This is one term, that is 25. The number of terms in this expansion, that is 25 terms. Okay. Another problem. Find the sum of last 20 coefficients in the expansion of 1 plus x whole power 39. In this expansion, we have to find the sum of the last 20 binomial coefficients. Okay, see that this is the solution. So what is here given? Given expression is given expression is 1 plus x whole power 39. So that is the given expression is 1 plus x whole power 39. In this expansion, we have to find the sum of last 20 coefficients in this expansion. What are the binomial coefficients? We have to write here. What are the binomial coefficients in this expansion? So in this expansion, the binomial coefficients are 39 C0, 39 C1, 39 C2, 39 C3, 39 C4 and so on, 39 C19, okay, 39 C20, 39 C21 and so on, 39 C39. These are the binomial coefficients. Now this is the binomial, these are the binomial coefficients. Now we have to find the last 20 terms coefficients sum. Now we have to find the sum of last 20. These are the last 20 binomial coefficients. Okay, so 39C20, 39C21 and so on, 39C39. Now we have to find the sum of the last 20 binomial coefficients sum. Now we have to find the sum of the last 20 binomial coefficients in this expansion 1 plus x whole power 39. Now see that what is the result? We know that the result, now these are the binomial coefficients. Now I have simply denoted C0, C1 and C2 and C3 and so on, that is C19, C20, C21 and so on, C39, C39. So these are the binomial coefficients simply denoted by, so NC0 is representing C0, NC1 is C1 and simply denoted the binomial coefficients C0, C1, C2 and so on, C39. These are the binomial coefficients. So okay, we know that the formula, we know that the result in previous C0 plus C1 plus C2 plus C3 and so on, C39 is equal to, so what is the well known, we have previously discussed the sum of the binomial coefficients C0 plus C1, C2 and so on, Cn is equal to 2 to the power of n. The sum of the binomial coefficients is the result 2 to the power of n. So here what is n? N is here 39. So the sum of the binomial coefficients is 2 power 39. So this is the result. This is the, we are knowing the result. The sum of the binomial coefficients is that is 2 to the power of n. Now we are writing the terms in this given expression 39C0 plus 39C1 plus 39C2 and so on, 39C19 plus 39C20, 39C21 and so on, plus 39C39, that is equal to 2 to the power of 39. So 2 to the power of n. These are the binomial quotients. So sum of the binomial quotients is 2 to the power of n. Now we are writing these are the first 20 terms, these are the last 20 terms. Okay, now we are writing this is 39c. Here the formula is NCR. Here the formula is NCR is equal to NC n minus R. We are knowing the formula NCR is equal to NC n minus R. Here 39C naught can be written as 39C 39 minus 0, that is 39. Okay, that is 39C 39 minus 1, that is 38. Okay, next 39C 39 minus 2, that is 37. Okay, and so on, that is 39C 39 minus 19. So that is 39 minus 19, that is 20. Okay, now we are writing this 39C naught, 39C1, 39C1, 39C, 39, 18, 39C, 19. We are using this formula NCR is equal to NC n minus R. This 39C naught can be written as 39C 39 minus 0, that is 39. So this 39C1 can be written as 39C 39 minus 1, that is 38. Like that we are writing 39C 19 is 39C 39 minus 19, that is 20. Okay, plus the remaining last 20 terms, 39C 20 plus 39C 21 and so on, 39C 39, that is equal to 2 to the power of 39. Okay, these values, these terms 39C 20, 39C 19 and so on, 39C 39, these terms and these terms are the same terms. Okay, so this is the sum of these two terms we are writing. These are the, each one is twice, therefore 2 into 39C 20 plus 39C 21 and so on, 39C 39 is equal to 2 to the power of 39. So these first 20 terms and last 20 terms are same. Now we are writing 2 times of these last 20 terms. Now moving to this to RHS side, then we are getting that is 39C 20 plus 39C 21 and so on, 39C 39 is equal to 2 to the power of 38. So this 2 is moving to this side, 2 to the power of 39 by 2, that is 2 to the power of 39 minus 1, that is 38. So the sum of the last 20 terms in this expansion of 1 plus x whole power n. In the expansion of 1 plus x whole power n, the last 20 binomial quotients sum is here we are getting 2 to the power of 38. Okay, see the another problem. If capital A and capital B are two quotients of x to the power of n in the expansion of 1 plus x whole power 2n and 1 plus x whole power 2n minus 1 respectively, then find the value of a by b, capital A by capital B. Here we have to given capital A is the quotient of x to the power of n in the expansion of 1 plus x whole power 2n, and b is the quotient of x to the power of n in this expansion 1 plus x whole power 2n minus 1. Then we have to find the a by b. Now we have to find the value a by b. See the solution. So here given that a be the quotient of x to the power of n in the expansion of 1 plus x whole power 2n. Given that capital A be the quotient of x to the power of n in the expansion of expansion of, what is the expression here? 1 plus x whole power 2n. So A be the quotient of x to the power of n, x to the power of n in this expansion 1 plus x whole power 2n. That is given, we are writing the quotient of x to the power of n in this expansion. So what is the here expansion? This expansion can be written as 1 plus x whole power 2n is written as sigma 2n CR x to the power of r. So in that we are writing the quotient of x to the power of n is the value of a. Okay. Now we are writing the, in this expansion, what is the quotient of x to the power of n? So we have taken r is equal to n, then we are getting the quotient. So what is the quotient to n? CR. Therefore the value of a, therefore a is equal to 2nc. We have taken x to the power of n. We are wanting the quotient of x to the power of n is nothing but, in the place of r we are taken n, then we are getting 2n cn is the quotient of that is the quotient of x to the power of n in this expansion 1 plus x whole power 2n, that is a is equal to 2n cn. Okay, for n is equal to r is equal to n, then we are getting the quotient of x to the power of n, that is the value of a. So here a is equal to 2n cn. Okay, and what is also given? Also given capital B be the quotient of x to the power of n in the expansion of 1 plus x whole power 2n minus 1. So what is the expression? 1 plus x whole power 2n minus 1 is equal to, so this expression can be represented in this 2n minus 1 CR x to the power of r. 2n minus 1 CR x to the power of r. Here b is the quotient of x to the power of n in this expansion. So for this we are getting x to the power of n. Put r is equal to n, then we are getting x to the power of n. Then what is the quotient here? That is 2n minus 1 into cn. So therefore the quotient of x to the power of n in this expression 1 plus x whole power 2n, that is b. b is equal to, we are getting 2n minus 1 into cn. Put r is equal to n, then we are getting x power n. That is the quotient is here 2n minus 1 r is we are taken n. Then b is equal to 2n minus 1 cn. So this is the value of a and this is the value of b. Now we are finding the value of a by b. Now we are writing the value of a by b. Now capital A by b. Now we have to find the value of a by b. What is a? A is 2n cn. What is b here? That is b is 2n minus 1 cn. Here a is 2n cn and b is 2n minus 1 cn. Now we are writing the NCR formula. Okay, now we are writing, this is the NCR formula. So here, what is here? 2n cn, that can be written as 2n factorial by 2n minus n into factorial into n factorial. That is we have taken, this is the 2n cn value. Next we are writing now we are writing the denominator value 2n minus 1 cn, that is 2n minus 1 factorial by 2n minus 1 factorial by 2n minus 1 minus n factorial into n factorial. So this is the denominator 2n minus 1 cn, that can be written as 2n minus 1 factorial by 2n minus 1 minus n factorial into n factorial. Okay, now we are simplifying this one. Now we are simplifying this one. A by b is equal to, here what is 2n factorial? that is 2n into 2n minus 1 factorial. This 2n factorial can be written as 2n into 2n minus 1 factorial. In denominator 2n minus n, that is n factorial into n factorial. In denominator is coming to the numerator. What is the denominator? Here 2n minus n, that is n minus 1 factorial, that is n minus 1 factorial into n factorial by, that is 2n minus 1 factorial. This 2n minus 1 factorial can be written as 2n minus 1 into, okay, we are writing 2n minus 1 factorial. Okay, so this is the 2n minus 1 factorial. So this 2n minus 1 factorial, this 2n minus 1 factorial is cancelled, and here n factorial, this is n factorial will be cancelled. So the remaining terms here, numerator 2n, here 2n into n minus 1 factorial. In denominator we are writing n factorial can be written as n into n minus 1 factorial. So this n minus 1 factorial cancel, and is also n is cancelled. Then we are getting 2. So therefore a by b is equal to, we are getting 2. The value of a by b is equal to 2. So that is, okay. See the problem. Find the quotient of x to the power of minus 6 in the expansion of 3x minus 4 by x whole power 10. Now we have to find the x power minus 6 quotient in the given expression. Okay. See the solution. The solution. So what is given expression? Given that the expression is 3x minus 4 by x, 3x minus 4 by x whole to the power of 10. So this is the given expression. Now I have to find the quotient of x to the power of minus 6. Now I have to find the quotient of x to the power of minus 6. First we have to write the general term. First we have to write the general term for this given expression. What is the general term? That is t r plus 1. T r plus 1 is, what is the general term? NCR x to the power of n minus r into a to the power of r. So that is the general term. Now we are writing the general term for the given expression, that is t r plus 1 is equal. Here what is n? 10. 10 cr into, what is the x? That is the first term 3x whole power 10 minus r into the second term, that is minus 4 by x whole to the power of r. So now we are simplifying this one, that is 10 cr into, here the constant 3 to the power of 10 minus r and minus 4 to the power of r. These are the constant terms, and here x to the power of 10 minus r, here in the denominator x to the power of r by x to the power of r. Okay. Now 3 to the power of 10 minus r and minus 4 to the power of r. Moving the first, then after we are writing x to the power of 10 minus r, the denominator x to the power of r. So that is 10 cr 3 to the power of 10 minus r minus 4 to the power of r into 10 to the power x to the power of 10 minus r minus r, that is minus 2r. That is the x to the power of 10 minus 2r. That is the power of x is 10 minus 2r. For we have to, here we have to find the x to the power of minus 6. For the quotient of, x to the power of minus 6. Here we are wanting the power is minus 6. Now we are equating this x power is 10 minus 2r equal to minus 6. Then we are getting x to the power of minus 6. From that we are getting the value of r. So here that is 6 is moving to this side, that is 16 is equal to r, r is equal to, that is 8. 16 by 2, that is r is equal to 8. Then we are getting r, what is the quotient of x to the power of minus 6. So now we are equating this is the quotient of x to the power of minus 6. So for this x power minus 6 we are equating this is minus 6, from that we are getting r. So therefore the quotient of therefore now we are writing here, therefore the quotient of x to the power of minus 6 in this in given expression is r is equal to 10c, what is r is 8, 10c 8 into 3 to the power of 10 minus 8 into minus 4 to the power of 8. So this is x to the power of minus 6. Now we are wanting the quotient, that is the quotient here 10cr 3 power 10 minus r into minus 4 to the power of r. So this is the quotient of x power minus 6 in the given expression, that is equal to, here 10c8 can be written as 10c2. 10c8 is 10c, 10 minus 8, 10 minus 8 is 2, that is 10c2 into 3 to the power of 10 minus 2, that is 2, into here power is even, that is 4 to the power of 8. So this is the quotient of x to the power of minus 6 in the given expression 3x minus 4 by x whole power 10. So in that expansion the x power minus 6 quotient is 10c2 3 square into 4 to the power of 8. Okay, to the another problem. Find the term independent of x in the expansion of root x by 3 minus 4 by x square whole power 10. In this expansion we have to find the term independent of x. That means in which term there is no x. So without x the term is we are identifying, that is the term independent of x. Now we have to find the term independent of x in the expansion of the given expression is root x by 3 minus 4 by x square into whole to the power of 10. So in that expression we have to find the term of independent of x. So that is the term no x value. Okay. See the solution. See the solution. Given expression is given that here the expression is root x by 3 minus 4 by x square whole to the power of 10. So this is the given expression is root x by 3 minus 4 by x square whole to the power of 10. Now in that we have to find the term independent of x. Okay, now we have to find the term independent of x. First we will write the general term for this expression. What is the general term? We are writing tr plus 1 is equal to, what is the general term? ncr x to the power of n minus r into a to the power of r. Now what is here tr plus 1? What is here n? N is 10 cr. What is the first term here? Root x by 3 whole to the power of 10 minus r. 10 minus r into, what is the second term? Minus 4 by x square whole to the power of r. That is the general term for given expression. Now we are simplifying this one. That is equal to 10 cr. Here root x means x to the power of 1 by 2. That is x to the power of 10 minus r by 2. That is 10 minus r by 2 by here 3 to the power of 10 minus r. We are separating numerator and denominator. The power is 10 minus r. So root x whole power 10 minus r. That can be written as x to the power of 10 minus r by 2. By denominator 3 to the power of 10 minus r. Into minus 4 whole to the power of r by x to the power of 2 whole power r, that is x power 2r. Okay, that is equal to 10 CR. Here the constants are minus 4 to the power of R by 3 to the power of 10 minus R. Here x to the power of here 10 minus R by 2 minus 2R minus 2R. Here this is the x power 10 minus R by 2. In denominator x power 2R. Moving to numerator, then we are getting x to the power of minus 2R. Now bases are equal, powers are adding. That is x to the power of 10 minus R by 2 minus 2R. So that is equal to 10 CR minus 4 to the power of R by 3 to the power of 10 minus R into x to the power of here 10. By LCM you are getting here 10 minus R minus 2 into 2 4R minus 4R minus R minus 5R. So this is the x power 10 minus 5R by 2. Now in this this is the general term. Now we have to find the term in which there is no x term. Okay, so there is no x term, that is term independent of x. So for eliminating x, the power is 0. The power will become 0. Then the x power 0 is 1. So for independent term of x, now we are equating the power of x is 0. Now we are writing here for term independent of x, for term independent of x, we are equating the power of x is 0. That is what is the x power 10 minus 5 R by 2 is equal to 0. Now we are equating the x power is 0. So the power is 10 minus 5 R by 2, that is equal to 0. From that we are getting 10 minus 5 R is equal to 0. That is 5 R is equal to 10, R is equal to 2. We are getting R is equal to 2. So for that R we are getting the term independent of x. What is the term? So what is TR plus 1? That is TR plus 1. That is T2 plus 1. That is T3. The third term is independent of x in that expansion. So the third term is the independent term in this expansion. Now we are writing this third term. We are writing T3, that is T2 plus 1. That is here. That is where substitute. That is term, that is 10 C. What is here? R is equal to 2. 10 C2, that is minus 4 to the power of R. R is here 2 by 3 to the power of 10 minus 2. 10 minus 2. This x power is, we are equating 0. Then this will be 0. This is the term T3 term is independent term. That is 10 C2 minus 4 whole square. That is 16 plus 16 by here 3 power 8. 10 minus 2, that is 8. So this is the third term. T3 is 10 C2 into 16 by 3 power 8. That is the term independent of x in the given expression root x by 3 minus 4 by x square whole power 10. So this is the term independent of x in the given expression. That is the third term is the independent term. Okay. See the another problem. Find the middle terms in the expansion of 3x by 7 minus 2y whole to the power of 10. We have to find the middle terms. So if there are sometimes only one is the middle term, and sometimes there are two middle terms in the expansion. So that is we have to find the middle term or terms in the given expressions. Okay. So see the solution. What is the given expression? That is given expression, that is 3x by 7 minus 2y whole to the power of 10. This is the given expression. Now I have to find the middle term. Okay. What is here? N. Here n is here what is the index? Here n is equal to 10. What is this 10 is the even or odd? It is even number, which is even number, which is even number. If the index is even number, then what is the middle term? So in that case, only one middle term. So therefore, that is t n by 2 plus 1 is only one middle term. In that case, if n is even, we are getting only one middle term. If n is odd, then we are getting two middle terms. Here n is 10, that is even number. Therefore, the middle term is t n by 2 plus 1 is only one middle term. That is the what is the term t? What is n? That is 10 by 2 plus 1. That is t 5 plus 1. That is t 6. Sixth term is the middle term. Therefore, sixth term is the middle term. Middle term in the given expression or in the given expansion. Okay. So we are writing that term. First we are writing that term, that is t6 is that is t5 plus 1. We are writing the term also. What is t6? That is t5 plus 1. Now what is here NCR? That is 10C5. Here n is 10, 10CR. That is 10C5 into first term, that is 3x by 7 whole power 10 minus 5, that is 5, into what is second term minus 2y whole to the power of r, that is 5. That is equal to here minus 1 to the power of 5, that is minus, we are getting 10c5 into here 3 by 7 whole power 5 into 2 to the power of 5 into xy whole to the power of 5. So this is simplifying. Then here 3 power 5 into 2 power 5, that is 2 into 3, 6 power 5, 6 by 7 whole power 5 into xy whole power 5. So this is the sixth term in the given expansion. That is the sixth term is the middle term. Here sixth term is the middle term in the given expansion. Okay. Okay, see the another problem. Find the middle terms in the expansion of 4x square plus 5 y cube whole power 17. So in previous question the power is even. In this question the power is 17, that is odd number. Okay, see the solution. See the solution. What is given expression? Given expression is 4x square plus 5y cube whole power 17. Here power is n is 17, that is odd number. Here n is 17, which is odd number, which is odd number. If index is odd, then what are the middle terms in this in that expansion? So what are the middle terms? T n plus 1 by 2 and t n plus 3 by 2 are the middle terms. Are the middle terms. Okay, in that there are two middle terms, t n plus 1 by 2 and t n plus 3 by 2. These are the two middle terms if index is odd. Here n is 17, that is the middle terms are t 17 plus 1 by 2 and t 17 plus 3 by 2. That is what is t 17 plus 1, 18, t 18 by 2, that is t 18 by 2, that is t9, that is next t 20 by 2, 10. These two are the middle terms, t9 and t10. These are two middle terms. These are the middle terms middle terms in the given expansion. There are two middle terms, T9 and T10. These two are the middle terms in the given expression 4x square plus 5y cube is the whole to the power of 17. So in that expansion, there are two middle terms. These are T9 ninth term and 10th term are the middle terms. Okay.